Hi, I hope you're having a good day. I'm just going to make this video on how to solve an equation. This is a really important topic to be able to know for GCSE, and once you get it, it becomes like second nature. So, what does solving an equation mean? Well, it means to get the thing that we want, so that could be an x or a y, also known as variables, by themselves, and we want one of them. And we want all the other stuff in that equation on the other side, okay? So how can we do this? We can either add or subtract terms. This allows us to move stuff from one side to the other so that we can try and get the thing that we want by itself by taking the other stuff away. And then the last step usually is to either multiply or divide by some number to get one of the thing we want. So this sounds a bit sort of out of the blue at the moment, but I'm going to show you what I mean here, okay? So I've written 5 examples and we're going to go through them. So this on the left here, top left, x minus 1 is equal to 3. What this is saying is that x is something we don't know, it's having 1 taken away from it, and it's 3. Now to a lot of you, you could probably see immediately that x is 4, because 4 minus 1 is 3. But let's say we didn't see that, okay? To cancel out this minus 1 here, I'm going to add 1, okay? And the idea of an equation is that both sides are equal, so whatever I do to one side, I have to do to the other. So I'm going to add 1 to the other side, okay? Now this minus 1 and this plus 1 over here, they cancel each other out, because minus anything plus that same thing will be 0. So we're just left with x on the left, and the right becomes 4, okay? So that's what I mean by adding things to move them to the other side, and we will see an example down here where you have to subtract things to move it to the other side. Okay, so next we have 2x minus 1 is equal to 3. So when I read this in my head, I see 2 times something minus 1 is equal to 3. Now the first step is, can I get those x's by themselves? Yes, I can. I'm going to cancel out this minus 1 by adding 1. And again, you must do the same to both sides. So on the left, I'm left with 2x, and on the right, I get 4, okay? Now this bit has another step. Before, we immediately got a single x being 4, but now we have got 2x is equal to 4. This is just saying 2 times x equals 4. So, to get one single x, we divide by 2 on both sides. So 1x is equal to 2, okay? Now below is a bit of a combination of the last two things, but it also introduces how we cancel out a plus term, like this plus 2 here. So this is saying 2 times something plus 2 is equal to 4. So first of all, let's get rid of that minus, what am I trying to say? Let's get rid of that positive 2. Okay, so let's take away the 2 from both sides. So now we're left on the left with 2x, and on the right we're left with just a 2, okay? You see how I've taken away 2 from something that was adding 2, so these like cancel each other out, okay? So if 2x is equal to 2, let's take that up here, divide both sides by the number 2, and we get x is equal to 1, okay? And a quick note, any number you can think of, let's just say 47, if you divide that number by itself, you always get 1. The same applies for letters. If I had x divided by x, I'd get 1, okay? So let's go up here. 3x plus 1 is equal to 6. So again, let's cancel out the plus 1 by taking away 1 on both sides to get 3x is equal to 6 minus 1, which is 5. Now here, you might be thinking in your head, there is no whole number that when we multiply it by 3 becomes a 5. However, equations don't have to have whole number solutions. They can have a lot of different things as solutions. So again, just divide by 3, because this is saying 3 times x is 5, but we don't want that 3 times, so we divide by 3. And we get x is equal to whatever 5 divided by 3 is, which I'm going to write as a fraction, okay? This here means 5 divided by 3. In general, it's quite a confusing thing to think about in the first place, but let me just move this board over a bit. A divided by b is the same as having the fraction a over b. They mean the same thing. Okay, So this one below is a combination of what we've done before. However, now we've got x's on both sides of the equation, and I'm going to move this just because it's getting a bit cluttered over here. Let's just go down here. Okay. So 2x plus 2 is equal to x plus 4. So we are trying to get the x's all by themselves. So I've got to move all the x's onto the left or to the right. Now I have got two options here. I can move them onto the left, and I would be taking this x away on this side and 1 away from this side to get 2 minus 1, sorry. It's just a single x plus 2 is equal to 4. Or I could have taken away the other bit. I could have taken away this 2x. And I would have got 2 is equal to 1 minus 2x, which is minus x, plus 4. However, it would have been better to do the first way. Both of these would work, but the first way would allow you to avoid a negative. And in general, before you move a term around, think in your head, is there a way that I can do this without creating a negative? I know 2 minus 1 is positive, but 1 minus 2 is not. So it makes more sense to move the x's onto the left in this case. So I will take it away from that side, and then I have to from this side because it is an equation, so we must do the same thing to both sides. We get x plus 2 is equal to 4. Now the x is still not alone, however they are all on one side. One thing we need to get rid of is that 2. So let's take away 2 from both sides. Now we get x is equal to 2. That is this solved. Okay, so this at the end now will be slightly more challenging because I'm going to do it in terms of letters, but I'm just going to try to show you that it is the exact same thing. So let's say I have ax plus b is equal to c. So this can be whatever you want. These a, b and c's could be your favourite numbers, doesn't really matter. This is how you solve it. So we have this plus b here. We don't want that plus b. We want to get the x by itself, so we're going to take away that b from both sides, and we're just left with ax on the left is equal to whatever c minus b is on the right. Okay. Now this is saying a times x is this. We don't want a times x, we just want a single x. So we divide both sides by a to get a single x. And as I was saying earlier, we can write this on the right as a fraction to show that we've divided by a. Okay. And I mean, that is the basics of manipulating equations. By manipulating, I just mean moving things around. I will make more videos on harder examples of this, so you could introduce powers, stuff like squares or cubes. You could introduce brackets, for instance, and you could introduce fractions. So you'll notice we haven't done any multiplying yet in any of these examples. Sometimes when you have fractions in your equations, you have to multiply to cancel out the fraction to get a single x. But I will go more into that in a later video. Have a good day.